In the second part of 11.4, we're just going to go a little further with circumference and arc length. And actually, we're going to solve for some unknowns in the arc length formula. Now, remember the arc length formula here. We know that if we're looking for the length of an arc, and I'm just going to do AL for arc length, you're looking at the portion of the circle that you're dealing with. So you look at the measure of the arc, whatever degrees you're looking at, out of 360. And that's a portion of the total circumference. And of course, for a circumference formula, you can put either 2 pi r or you can put pi d. It just depends if you have radius or diameter. But this is our arc length formula, and today it's not just finding arc length. It's maybe you have arc length and you need to find the measure of the arc, or you need to find circumference or radius or diameter. So in this first example, I want to find circumference. Like, that's what I'm looking for. And I know right now that this arc length is 6.82 centimeters. Okay? So when I start out this formula, I know the arc length. Right now the arc length is 6.82 centimeters. And that equals whatever the measure of the arc is out of 360. Well, this arc length of 6.82 corresponded to an arc measure of 75 degrees out of total 360. Now, this is a portion of the total. You know what? If I want circumference, I don't need to put 2 pi r. I don't need to put pi d. I'm just going to put c here, because I'm told to find circumference anyway. Okay, so I have to solve for c. I know an arc length of 6.82 corresponds to 75 out of 360 degrees of my total circumference. Solving for that circumference. In this case, you're multiplying by a fraction, and to get rid of the fraction, we know we multiply by the reciprocal. So multiplying by 360 over 75. So I'm doing 360 divided by 75 times that 6.82. And for circumference, I am getting 32 point, I'm just going to be exact, 736 here. The arc was 6.82 centimeters, so the whole circumference is 32.736 centimeters. And that seems reasonable. 75 degrees, so that's less than a quarter of the circle, was almost 7. And like if it was a quarter, 7 is towards 28. This is a little more than that because this is a little less than a quarter. Sounds good at 32.736 centimeters. Okay, so we solved for an unknown, we solved for circumference in the first one. In this next example, I want to find the measure of arc AB. So I need like the central angle measure or the arc measure. I know the length of arc AB is 40 feet. I know the radius of the circle is 15.28 feet. Use the formula. I know the length of an arc. I know the length of arc AB is 40 feet. So 40 equals the measure of the arc out of 360. Well, I'm looking for the measure of the arc. Measure of arc AB is unknown out of 360. And that's whatever portion of the total circumference. I don't know the circumference itself, but I do know one of these formulas. The radius is 15.28, so I should use 2 pi r for that circumference. 2 times pi times 15.28. Sorry, that looks bad here. 2 times pi times the radius of 15.28. There we go. Now, solving for this, there are a few different things you could do to solve. It's kind of up to you how you want to go about this. I can tell you what I think the easiest way to solve is maybe just multiply all this stuff first. Okay, so I have the measure of my arc out of 360 times, well, what is 2 times pi times 15.28? That part I'm doing on the calculator right now. Oh, actually, it's like 96. I guess 96.01 technically. And then maybe my next step would be try to get the fraction alone. So this is being multiplied by 96.01. I'm going to divide by that answer that I had in my calculator. So 40 I'm going to divide by my answer. And I get 0.4. I'm going to go a lot of decimal places here to be accurate. 4166. Now that equals the measure of arc AB still over 360, right? That's what's left over here. And then my last step is to get this arc alone, it's being divided by 360, so multiply by 360. So I'm keeping that answer in my calculator times 360. And I get, well, it's 149.98 or 99. I'm going to kind of round up here and say 150 degrees equals a measure of arc AB. Okay, so there we did a problem where we were looking for that unknown measure of the arc. Again, there are other ways to solve for this unknown. Like I could have done 2 times pi times 15.28 divided by 360 right away and just gotten a decimal here and then divided on both sides. It's kind of up to you. Let's try another example where we're solving for an unknown in our arc length formula. Again, remember that arc length is whatever portion that arc is of the circle, so whatever the arc is out of 360 times the total circumference. And it looks like I'm trying to find radius. I have an arc length. This is 10.5 feet. I know the measure of that arc is 150 degrees out of 360. I need the radius, so for circumference I'm definitely going to put 2 pi r since I need radius. Alright, arc length, 10.5 feet is the length of an arc. That is 150 degrees out of a total of 360 degrees. Of that total circumference, and since I'm looking for radius, they're telling me to find radius, circumference, I'm going to put 2 pi r. Now, if I'm going to solve this, I would just do all of this on my calculator, figure out a decimal in front of that r, so I'm going to do 150 divided by 360 times 2 times pi. Some of you might be wondering, could I have multiplied by the reciprocal there? Yeah, absolutely, and then you would divide by 2 and pi. There are a lot of different ways to solve for this. It's just kind of whatever you feel the most comfortable doing. When I did this whole thing, I got 2.618 about, still times that r, and then I can just divide by 2.618. So 10.5 divided by the answer I just got. And I get 4.01 for my radius. And I guess the arc length was in feet, so the radius would be in feet as well. Okay, so some practice today, solving for an unknown using the arc length formula, whether you're looking for circumference or the arc measure or radius or diameter. And then I have one sort of real life problem here using circumference and an arc length type thing. Track and football field is shown below, and this is not quite to scale, but this is kind of like ours actually, where the football field is surrounded by the track, right? The track is going around that football field. I exaggerated the size of the track just so we can work with it here. A semicircle is formed at each end of the track. Well, that makes sense if you drew these lines. This is a semicircle, and if you drew these lines here, another semicircle, right? So it's like if you put these two together, you'd have a full circle there if you ignored this middle part. Let's see here. The inner circle radius is 80 feet. Oh, and you can tell that that's right here. Like the track, or to the edge of the track is 80 feet to the edge of the football field. The outer circle radius is 120 feet. This 120 means all the way to the edge of the track, so this entire length is 120. And actually, since this much is 80, then this portion here is 80. And then if this whole thing is 120, what's the distance on the track? Well, 120 minus 80 would be 40. Again, I told you this wasn't quite to scale there. Okay, because 80 and 40 would be 120 total. Find the distance around the track for a runner in the middle. Distance around the track for a runner in the middle. So this runner is going to be in the center of the track and going to run all the way around. Actually, I'm going to say I'm starting here. I know this distance, isn't that just 300? That part's easy. Now we're in the middle of this track, going around. This is half of a circle. I need to find that distance. Then we're going to run this straightaway, which again is another 300 feet. And then we're going to do our semicircle loop at this end. Another semicircle or half circle there. Well, I know the straightaways are a total of 600. That's easy. 600 feet, right? 300 and 300. But I need to know the distance we're running around the track. So 2 semicircles. 2 semicircles equals just 1 circle, doesn't it? If I put these 2 semicircles together, I'm just doing 1 circle, ignoring this part in the middle. I could probably actually do that just by grabbing this. Right? There's my full circle. So I already did the 600 straightaway, and I'm going to do 1 circle. Well, it's the distance around a circle, so I need 1 circumference. What's the formula for circumference? 2 pi r or pi d? I'm thinking I'm going to use 2 pi r here. Question is, what's the radius of this circle? If I'm going to the middle of the track, that means I'm doing 80 plus half of that 40. So 80 plus 20. Wouldn't that be 100? Because it would only be 20 feet here. So my radius is 100 feet. Let's see, what is 2 times pi times 100? 628.32 feet. Now that's, again, I put both of these together. I made 1 circle because it was 2 semicircles. I have the 600 feet as well. So I'll combine the total distance here. And we're going, what, 1,228.32 feet. That would be the total distance around the track if you were exactly in the middle. So again, today solving for some unknowns, dealing with arc length formula, and just looking at some more applicable uses of circumference and arc length.